21, I believe, in section, what was it, 6.3? Right? Something like that. Anyway, how many permutations of letters A, B, C, D, E, F, G contain the string B, C, D? So, we've got a set of A, B. I need you to think about this problem the same way I do in order to understand it, right? So, and this will really help you kind of understand permutations a little bit. When you permute a set, you get the possible outputs of, or you get the all possible combinations of this set. So like, if I permuted this, I would get like, what is a 7 factorial? Right? I would get that many combinations, right? If I just permuted that, and we want to know how many. What's 7 factorial? Is 120 by 7, right? Yeah, it's 120 times 7. Whatever that is, it's a lot. 8. What is that? Jesus. What's 6 factorial? I don't know. Let's calculate it right now. Times 4 times 3 times 2 equals 5,000. Okay, so out of the 5,040 different combinations of these 7 elements, right, we want to know how many of those 7 bit strings, if you want to think of them as bit strings. I mean, that would make it easier, certainly. You want to think of them as element strings. How many of them contain the string B, C, D? And suddenly this becomes one element, right? And so now you only have 5 elements because you treat B, C, D as one element, right? So how many of these 5,040 are going to be in this new set of 5, right? Well, we're not going to do like some sort of complicated division, right? We don't want to overcomplicate things. Just look at this as right, picking from the set of, what is it, B, C, D? A, B, C, D, E, F, and G. And what that means is you're just going to permute the set of, what is it, 1, 2, 3, 4, 5. Right? So what's 5 factorial? It's 120. And there you go. That's your answer. Right? Let's do part B. The string CFGA. So once again, we're going to take our set and we're going to make it into CFGA, which means we're going to have, we'll just put it at the front. Crap. Why did I pick the wrong eraser? This one might work better. It does. Okay, excellent. C, F, G, A, B, D, E. Right? Yeah. So we've got this set, right, and we want to permute it. Right? How many permutations can we get from this new set here? Right? And that's 1, 2, 3, 4. So 4 factorial is just going to be 4 times 3 times 2, which is 4 times 6, which is 20, just 24. 24. Okay? And let's do part C, the strings BA and GF. So now we have BA, we have GF, we have C, we have D, and we have E. So once again, we have 5 elements, and we want to permute them. So I think we're just going to get, let's double check this answer, because I don't think it's going to be 24 again. Okay. Never mind. It may actually be a repeated answer from before. So, how many elements do we have? 1, 2, 3, 4, 5. Yeah, so this is just 5 factorial, which is 120. Okay, I was kind of surprised that we got that answer again. But yes, that is the answer to C. Now let's do D. Right, the answer D is how many can we get from the set of A, B, C, and D, E. D, E, F, and then G, right? And so we have 1, 2, 3, 4 elements, so that's 4 factorial, which is just 24, right? And so let's do E with the strings A, B, C, and C, D, E. Well, that look at what the strings A, B, C, and C, D, E look like, right? You can't have A, B, C without having C, D, E. It's impossible because they share this C. You gotta have A, B, C, D, E as one element in your set, and then F, and then G, right? So that's really just 3 permuted, which is 6. Let's make sure I got that right, because that would be bad if I did not. Right? Like, what else could it really be? Yes. Okay, and let's go back to the last one. What was the last one again? CBA and BED. Okay, well, is that even possible? Right? Let's write out the set A, B, C, D. I'm skeptical to whether or not this is actually possible. Right? You've got these elements, and you want to get a bit string, right, or string of elements, whatever you want to call it, with the terms. I'm going to write it as impossible as possible. BED and CBA. You simply cannot have 2 B's. It's not allowed. You're only allowed to take every element one time, so this is definitely not allowed, right? And you couldn't try reordering this in such a way that you can get both of these. It's literally impossible because this B is surrounded by this C and this A. So there is certainly no way that you could put an E after this B. You simply could not. So there are 0 ways that you could answer this problem, and that's the end.